I'll start with the dictionary definition of a reference angle. A reference angle is also known as theta prime. Theta prime is defined as the acute angle formed by the terminal side of theta and the horizontal axis. In this image, we will start by looking at the image on the top right. This is an angle, theta, and its reference angle, labeled in the picture as B. When theta's terminal side falls in quadrant 1, theta prime is equal to theta degrees. Moving to the image on the top left, this terminal side of theta falls in the second quadrant. Theta prime is formed by the terminal side of theta and the horizontal axis. When the terminal side of theta falls in the second quadrant, you can find theta prime by subtracting theta from 180 degrees. Looking at the bottom left image, you can see that the terminal side of theta falls in the third quadrant. Theta prime is the angle that is formed by the terminal side of theta and the horizontal x-axis. You can also find the measurement of theta prime when the terminal side of theta falls in the third quadrant by subtracting 180 degrees from the measurement of theta. Finally, we have the image on the bottom right. The terminal side of theta falls in the fourth quadrant. Theta prime can be found in this case by subtracting theta from 360 degrees. I'm going to explain each part of what I just explained more slowly by drawing each of the angles I just described. In this example, the angle is going to fall in quadrant 2, which means that its reference angle is going to be the angle that's formed in order to make it 180 degrees. So there's theta, and right there is theta prime. In this example, theta is going to fall in the third quadrant, which means that theta prime, since it's the acute angle formed by the terminal side of theta and its horizontal axis, that is going to be theta prime right there. In this third example, the terminal side of theta falls in the fourth quadrant. Since a reference angle, or theta prime, is formed by the terminal side and the horizontal axis, there is theta prime right there. Okay, now I'm going to show you how to actually find the reference angle given an angle measurement. So right here, we have 217 degrees, and we're trying to find its reference angle. So first we need to determine which quadrant 217 degrees would fall. So starting here, I know that it's not going to be the first quadrant because this would only be up to 90 degrees. We also know that it's not going to be the second quadrant because this would be up to 180 degrees. Now, if it fell in the third quadrant, it would be between 180 degrees and less than 270 degrees. So 217 is obviously greater than 180, but less than 270, so we know that it falls in the third quadrant. So we can draw the angle here, and this is going to be theta. Now, since we know that it falls in the third quadrant, we're going to use its terminal side and the closest horizontal axis to determine the reference angle. So this is not the closest horizontal axis because if you just look at the picture, it's obvious that this one is closer. So we're going to use the terminal side, which is this, and the horizontal axis to determine that this angle right here is theta prime. Now, we are going to, in order to find this, we're going to want to subtract 180 degrees from 217 degrees. Because if you just look at the picture, if this is the reference angle, and this is the whole angle, we want to get rid of this part, the 180 degrees part, to determine the reference angle. So we're going to do 217 minus 180, which is 37 degrees. So now we just found out that the reference angle of 217 degrees is 37 degrees.
How to find the reference angle using radians. So the example that we're going to be using today is 11 pi over 4. Now what I'm going to start by doing is labeling each of the axes starting from 0 to pi over 2 to pi to 3 pi over 2 and then finally to 2 pi. So next, since our example is 11 pi over 4, I'm going to be converting all of the axes to a common denominator of 4, starting from 0 to 2 pi over 4 to 4 pi, then at the bottom we're going to have 6 pi over 4. Then back to 8 pi over 4, which is equal to 2 pi. So that's one full rotation. Then up to 10 pi over 4, and then all the way to 12 pi over 4. Now the reason why I stopped at 12 pi over 4 is because we know that the reference angle will not be greater than 12 pi over 4 due to the fact that our example only is only 11 pi over 4. So now that we have those labeled, I'm going to draw the angle on which 11 pi over 4 will be, and that is in quadrant 2. I'm going to draw and show where it starts and where it ends, and I'm going to label that theta. Now this remaining part, the reference angle, will be labeled theta prime, and that is what we're going to try and find. So I'm going to label this 11 pi over 4 so we do not forget. And then I'm going to show you how to find the reference angle. So the reference angle is also the acute angle labeled theta prime. And to find that, I'm going to take the angle formed by the terminal side of theta and the horizontal axis, which is the horizontal axis is 12 pi over 4. I'm going to subtract 11 pi over 4 from that, and I'll get pi over 4. So theta prime, also known as the reference angle, is pi over 4.
First, I'm going to find the reference angle of 120 degrees. Using what we know about reference angles, we can find that the reference angle of 120 degrees is 60 degrees. We know that trig functions of theta prime are equal to plus or minus the trig function of theta. Using the unit circle, we can find the sine, or the y value, of 120 degrees. So looking on the unit circle, you can see that it is root 3 over 2. Okay, now we're going to find the sine of 60 degrees. So we look on the unit circle, and the sine is also root 3 over 2 for 60 degrees, which proves that trig functions of theta are equal to plus or minus trig functions of theta prime. Now I'm going to do an example using radians. So we're going to find the cosine of 4 pi over 3. First, we want to find the reference angle of 4 pi over 3. Again, using what we know about reference angles, we can find that theta prime for this example is equal to pi over 3. Now we're going to look at the unit circle and find what the cosine of pi over 3 is. And it is 1/2. Okay, looking at this graph, we know that the cosine is equal to the x value. So the terminal side of theta is obviously in the negative x values, so we know that the cosine of theta prime has to be negative 1/2.